Hi everyone, I am Major Salas Conde, the second reporter of Group 4, Time Value of Money. So we're discussing about the future value versus the present value. Future value and present value are monetary concepts that a business owner uses every day. These concepts are used when evaluating investments and projects because these calculations will provide basic data on which to make rational business decisions. They are also applied in various ways, such as calculating growth rates, earnings per share, expected sales, and revenues in the future, and so forth. The present value is the sum that must be invested now to guarantee a desired payment in the future, while the future value is the total amount that will be achieved over time. So let's now go into deeper in discussing of these two concepts. Future value. It is the amount of money that an original investment will grow to be over time at a specific compounded rate of interest. So it is a sum of money that will accrue over time when it is invested. Future value is calculated using this formula where if V is the future value is equal to PV, the present value, or the initial principal, multiplied to 1 plus R, the interest rate, to the power of N, the number of periods. So let's now have an example problem of computing the future value. If you deposit 1,000 pesos in an account that pays 5% interest rate compounded annually, how much will you have at the end of 10 years? So let's first compute the future value of year 1. We have a 1,000 present value multiplied to 1 plus 5% to the power of 1 since we only compute the first year. So the result of this one is 1.05, and then we will multiply it to the present value of 1,000. So we have a future value at the end of year 1, 1,050 pesos. So let's now to compute the 10-year period. We have 1,000 present value multiplied to 1 plus the 5% to the power of 10, the 10 years. So the result of this one, 1 plus 5% to the power of 10, we have a 1.6289. And then we will multiply it to the present value of 1,000. So we have a future value after the 10 years, 1,628 pesos and 90 cents. So let's now move on to determination of future value using a table. Instead of computing the value of the term 1 plus r or the interest rate to the power of n, we will use the future value interest factor or the FVIF. We will use by finding it, we will use the table, the future value interest table. So muna siya ang future value interest table that has a different time periods and interest rates combination. So how will we find the FVIF of this sample problem? Since we have a 5% interest rate and 10 years, so we will use it in finding the FVIF using this table. So we had a 10-year periods and the 5% interest rate. Now we have a value of 1.6289. We usually rounded it off to decimal places. So we have a 1.629, and then we will multiply it to the present value of 1,000. So we have a future value of 1,629 pesos. So as you can see, they are almost the same answer. So if we will round it off, the future value of using this formula is 1629. So they are almost the same answer but with a different kind of method. The 72 rule. The 72 rule is a quick but approximate method of determining how long it will take for a specified sum to double in value. So it means kano sa madoble ang atong principal value. So to be able to come up those years, we will use this formula. Approximate years to double is equal to 72 divided by or the rate. Um, we have a 5% interest rate of this problem. So 72 divided by the 5 divided by the 5, we have approximate years to double 14 years. So it took 14 years to double our principal value 1000 to make it 2 years to make it 2000 pesos. So let's now move on to future value with intra-period compounding. Compounding that occurs more than once a year is called intra-period compounding. The future value for a compounding period occurs annually, semi-annually, quarterly, or monthly. So then the future value formula must be modified to reflect the number of times per year compounding occurs denoted by M. So this is a formula of future value with intra-period compounding. Future value is equal to present value multiplied to 1 plus the interest rate divided by M, the number of compounding periods to the power of N times the N, the number of years. So still we will use the same sample problem, but it is compounded semi-annually. If we deposit 1,000 pesos in an account that pays 5% interest rate compounded semi-annually, how much will you have at the end of 10 years? You have a present value of 1,000 multiplied to 1 plus the 5% interest rate divided by 2 since it is semi-annually, so 2 siya to the power of 2 times 1. So we have a future value of 1,050 pesos and 63 cents at the end of year 1. So let's now compute 10th year period. 1,000 multiplied to 1 plus 5% divided by 2 to the power of 2 times 10. So we have a future value after 10th year period. So we have a 1,638.62 future value. So okay, let's compare the semi-annual period with the annual compounding period. As you can see, there is an increase in the of 9 pesos and 72 cents sa compounded semi-annually. So increasing siya. The more because the more frequent of compounding period, the more interest is earned. So mas preferable dyan ang compounded semi-annually. Kaya maka-earn kag greater interest than compounded annually. Annual percentage rate is also called effective annual rate. Effective annual interest rate is the real return on a savings account or any interest paying investment when the effects of compounding over time are taken into account. It will also reveal the real percentage rate owed in interest on a loan, a credit card, or any other debt. So this table shows the increasing of effective annual rate. So the problem before, we have a 1,000 pesos present value and a 5% interest rate. In annual compounding period, we have a 1,000 1,050 pesos and a 5% effective annual rate and compounded annually. Okay. While the semi-annual compounding period, we have a future value of 1,050 cents. So this one, 1,050 and 63 cents, and has a effective annual interest rate of 5.06%. So to compute this, we need to use this formula. APR is equal to 1 plus or the interest rate divided by the M, the number of um, compounding period out. So the wait number of compounding period lagi to the power of M minus 1. So let's now substitute 1 plus the 5% interest rate divided by 2 to the power of 2 minus 1. So we have an APR, annual percentage rate, semi-annual compounding. So we have a 5.06%. Well, and lastly, the quarterly, we have a 5.09 effective annual interest rate. So to compute this, we will now substitute 1 plus 5% interest rate divided by 4 since it's quarterly, the power of 4 minus 1. So we have a effective annual interest rate and quarterly compounding period of 5.09%. So overall, nakita nato na there is an increasing of effective annual interest rate because why? The more frequent the compounding periods, the greater the return. Diba? Okay, let's now talk all about the present value. Present value is the current value of future amount of money or a series of payments evaluated at an appropriate discount rate. Present value oh, determination discounts money that will be received in the future but back in time to see what it is worth in the present. So discount rate, or also called as a required rate of return, is the rate of interest that used to find the present values. Discounting is the process of determining the present value of the future. So the present value is also called a discounting technique. Okay, so this is the formula of finding the present value. Present value is equal to future value divided by 1 plus interest rate or the discount rate, the Or we have the present value is equal to future value divided to 1 divided by 1 plus the discount rate or interest rate to the power of n. Okay, let's now have an example problem. Excuse. Suppose you are depositing an amount today in an account that earns 5% interest compounded annually. If your goal is to have 5,000 in the account at the end of 6 years, how much must you deposit in the account today? So let's now substitute. We have a future value of 5,000 divided by 1 plus the 5% interest rate, the interest rate to the power of 6. So the result of this 1 plus 5% interest rate to the power of 6 is 1.401. So our present value um is equals to 5,000 divided by 1.3401. So we have a present value of 3,731. Okay. So this is the sum of 3,731 is the present value today of the 5,000 to be received 6 years from now. You will notice that there is an inverse relationship between the present value and the future value. Um, the present value of 3,731 is the present value of 5,000 to be received 6 years from now if the rate of return is 7%. Or alternatively, 5,000 is the future value of 3,731 invested for 6 years with an interest rate of 7% by using the future value formula. Okay, let's now move on to determination of present value using table. Um, Instead of using this term, 1 divided by 1 plus the interest rate to the power of n, we will use the PVIF. Present value interest factor. Through the so we will use the present value interest table with values with different time of periods and interest rates. Pero take note, lahi si present value interest table kay ni future value interest table. Kaya lahi silang values. So let's now solve the present value using the table. Okay, we have a 5% interest rate and the 6 years of period. Okay, 10 years, we have 6 years period, rather, we have 6 years period and 5% interest rate. So we have a value PVIF of 0.74622 PVIF. And we'll multiply it to the 5,000 present value. So we have a present value of 3,731 by using this table. So, so now let's tackle about the frequent discounting. In frequent discounting, there will be a frequent period of discounting in a year. Just like the future value intra-period compounding, there are periods during the year. semi-annual, quarterly, and monthly. First, to get the formula of frequent discounting, we will convert the future value intra-period compounding into the frequent discounting formula. So we will have a present value is equal to future value divided by 1 plus interest rate divided by the um, m, the number of compounding periods during the year to the power of n times n, the number of years. So let's have an example. Suppose you are depositing an account today in an account. Oh, wait. Suppose you are depositing an amount today in an account that earns 5% interest rate compounded semi-annually. If your goal is to have 5,000 in the account at the end of 6 years, how much must you deposit in the account today? So compounded semi-annually siya. So let's make substitute. Our future value is 5,000 divided by 1 plus 5% interest rate divided by 2. So semi-annual siya. To the power of 2 times 6 years. So we have a 5,000. Oh, wait. So the result is, so our present value, so our present value is 793 and 18 cents. Okay, the relationship between future value and present value. This table illustrates the relationship between present value and future values at the end of corresponding time period for a starting sum of 5,000 at an interest rate of 5%. In row 1 in the table shows the time period in years, starting with the present time, which is designated with time 0 until the 6 years period. In row 2, we have an FEIF. It sets out the FEIF, the future value interest factor. Okay, let's find out the FEIF in this corresponding years with 5% interest rate. So um, we have 6 years, right? We have a period of 6 years. And with the corresponding, we have a 5% with the corresponding years. In year 1, we have a 1.0500. In year 2, we have a 1.1225. In year 3, we have a 1.15. In year 4, we have a 1.2155. In year 6, we have a 1.273. So, this is our FEIF. In row 3, we have the future compounded value of the original amount of 5,000. We will multiply the FEIF to this original amount. In year 1, 1.050 times the 5,000, we have a future value of 5,250. In year 2, 1.103 multiplied by 5,000, we have a future value of 5,515. In year 2, 1.158 times the 5,000, we have a future value of 5,790. In year 4, 1.216 multiply to 5,000, we have a future value of 6,080. In year 5, 1.276 VIF multiplied to 5,000, we have a future value of 6,380. And lastly, year 6, an FYF of 1.340 multiplied to 5,000, we have a future value of 6,700. And in contrast, row 5 in the table that displays the relevant present values for the same time periods calculated using the respective present value interest factor. So our present value interest factor, then we will now refer the interest present value interest factor with the corresponding years. Okay. Um, we have a 5% interest rate for the corresponding years, 6 years, the last of 6 years. So we have in year 1 we have a 0.95238. In year 2, 0.90703. In year 3, we have 8.86384. In year 4, 0.82270. In year 5, 7.8353. Well, lastly, also to 1, 2, 3, 4, 5, 6. Year 6, we have 0.78353. So this is our PVIF. So let's now multiply our PVIF into the original amount of 5,000. In year 1, our PVIF is 0.952. Multiplied to 5,000, we have a present value of 4,760. While the year 2, 0.907, we have a present value of 4,535. In year 3, 0.864 PPIF multiplied by 5,000, we have 4,320. In year 4, we have PVIF of 0.823 multiplied by 5,000, we have a 4,415 of present value. For the fifth year, 0.784 PVI multiplied to 5,000, then we have present value of 3,120. And lastly, in 6 years, 0.746 PVIF, the present value interest factor, multiplied by 5,000, we have present value of 3,730. And comparing row 3 and row 5, you will see the inverse relationship between the future value and the present value. So as you can see, oh, as you can see, um, increasing ang future value, increasing future value, while our present value is decreasing. So overall, there is a inverse relationship of between future value and the present value. Okay, that's it. Thank you for listening.